Alright, welcome everybody. In this video we're going to talk a quick introduction to the slope deflection method. And this method is generally used to figure out what reactions are on indeterminate structures. So let's say we had a beam and it was fixed here at A and it was fixed here. So this is A, this is B, and there's whatever loading. We don't know what the loadings are, but anyway, here you have 6 unknowns. So this is obviously indeterminate, and we can use the slope deflection method to figure out what these reactions could possibly be. In your classes, you should have an equation something like this. You should have seen it before. 2EI over L is equal or times 2 theta I plus theta B or theta J minus 3 times psi of I times J plus any fixed dead moments, right? And I and J, basically, they correspond to the ends of the member. So in this case, we had member AB. If I were to cut near the joints and then redraw this member, right? This member A. What am I doing? A, B. I'd have a moment on the A side and a moment on the B side, and this would be MAB, right? IJ would be AB because it's on A, so that's why A comes first, and then on this side it'd be MBA, right, because it's on side B of the member. So it's flipped, MBA. And theta, these thetas are the slopes at these points. And these are generally the thetas and the psis here are what we don't know. But we can figure out what these are to solve for the moments at the ends of these members. And these moments later on will give us the reactions at A and B or whatever support you're looking at. This psi here is a chord rotation, so if any of these members on a structure we're studying rotates, not deflects, rotates, then there's a rotation. This I think is usually given in radians. So if we had, let's say we had an indeterminate frame, right? And I applied a 30. Let's say some force P here, right? This beam would do something like this, right? Right. It would member A, B, well, let's just label it first. A, B, C, D. Member A actually rotates. The chord rotates. So by chord I mean the point from here to here. That's usually a straight line, right? So if this thing rotates, then that means this distance or this angle is psi. Okay, same thing here. You have this point and you have this point. It's chord, meaning the point from those 2 points, or the line from those 2 points. This angle here is psi. That's the chord rotation. Okay, normally that only happens in frames, sometimes in beams, but not too often, or at least not in the problems we study. Right. The next thing I want to talk about is sign convention. So if let's say you cut this AB, you cut this member AB, sign convention for the slope deflection method when you're drawing these moments is clockwise for the ends of the members. Always. This is clockwise, this is clockwise. If you had a frame, you'd probably set up a local coordinate system, right? So if you had this frame, and I cut it, let's say here and here, here and here, here and here, and I'm looking at these members. I have this member, I have this member, and I have this member. The moments at the ends are always clockwise. This is the sign convention we use. Clockwise. clockwise. And this sign convention is pretty consistent with a lot of the structural or fundamental of structural analysis textbooks and whatnot. So remember the sign conventions for these moments, the moments you're trying to figure out with this long equation, is always clockwise. Okay. Now you also have these joints. I didn't draw these joints here. Joints have a special sign convention. Their sign convention depends on the member sign convention. So in this case, for this frame, if we had, let's see, let me draw this exploded frame again. You have these three pieces, and then you have this joint, you have this joint, then you have this fixed end here, then you have this fixed end here, right? This is A, B, C, and D. Right, so if I said member AB, the moment here is clockwise. So this is MAB and MBA. That means on joint B on this side, it's going to be, when you cut something, the other side is always equal and opposite. So this moment is going to go this way, and that's moment BA, right? And on member BC, you draw your sign convention, or your moments at the end of the members. They're always clockwise. And again, at joint B, on member BC, you have this moment going clockwise. So that means on this joint, the moment's going to be going counterclockwise, right? Equal and opposite, equal magnitude, opposite direction. So this is MBC. Same thing for C. This is going clockwise. This is going to go counterclockwise. On member CD, this is clockwise. So you have equal and opposite. That's going clockwise. That means this is going to go counterclockwise. And this is M. Both of these are MCD, the moment at CD. Same thing for this joint. This is going clockwise. This is going to go counterclockwise. And both of these are MDC. And up here, this is MCB. Okay, so whenever you have a beam or a frame, these are the sign conventions used for the members and the joints. Now, if you had a beam, and it was fixed here, it was fixed here, there was a roller here, there's a roller here. Let's call this A, B, C, D. I can cut this beam here and here, here and here, here and here, and I can draw this joint A. Here's joint A. Then I have span AB, AB, or sorry, AB, and then I have joint B, which is this, right? Then span BC. Then I have joint C, and then you have CD. I'm actually going to draw it down here because I'm running out of room. C, D, and then you have the fixed end D, right? Here, your sign convention for members are always clockwise. So clockwise, 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 clockwise. And for the joints, here it's equal and opposite, right? This is clockwise, this is counterclockwise. Same thing at the joints. You have B going this way, so that means the moment here is going to go that way. Same thing for here, equal and opposite. Here it's going clockwise, that means this is going to go counterclockwise. On the right side of this joint C, this is going clockwise, so that means on this side it's going to go counterclockwise. And same thing here, you have this, and then you have this, right? So this is kind of the sign convention we use for slope deflection. And in the next several videos, actually many videos, we'll do a couple different examples. I believe 2 beams in 1 frame. Alright, so see you in those.